In this video, I'm going to go over 1.1 daily problem. This is for my Math 261 Applied Calculus 1 class. The notes from today, section 1.1 and half of 1.2 that I scanned are posted on Canvas for you if you miss any parts of it. So you can look at those too for more resources. But what we're doing in this daily problem is like looking at a graph like this, evaluating limits and a couple of the function values that I'm going to ask. So if you can click on, if you open up daily problem 1.1, and if you don't need me, you don't have to watch this video. You can stop this and just try on your own, because you do have unlimited attempts on this daily problem. So you can keep on taking it until you get 100%. But if you're at a point you just don't understand what mistake you made, because I think I did set it so that you can see which problem you missed, but it doesn't tell you what the correct answer is. So if you keep on missing the same problem over and over again and getting frustrated, you can maybe fast forward this video to find that one problem, because I know the questions are going to be scrambled. So my number one is going to be different from your number one. But I'm going to go ahead and launch this quiz and try all 12 problems, and I will submit it to see if I can get 100 on this. Okay. All right, I did make this, but I do sometimes make silly mistakes like sign mistakes. So let's take a look. All right, loading. Oh, what's going on? Come on. Okay. Consider the function f graphed. It's a crazy looking function, isn't it? I'm not sure if I created this function myself or if I just got the picture copied somewhere. But let's see. Find each limit or function value if it exists. So the first one is not a limit problem. It's asking me to find f of 4. So what it's asking is, where x is 4, where is a function value? Where is a y value? So this one is pretty easy. So where is x equals 4? Because I do want to write on this, guys. So I think I'm going to go ahead and take a picture of it and then write on it. Let's see if I can write on this. Yeah, why not? So f of 4 is the y value at x value of 4. So where's the point at? Now I got a problem though. Do you guys see that we have an open circle at x equals 4? So I cannot say f of 4 equals 2. That is not true, because we have an open circle there. Now, in order for me to have a function value, I better have a closed circle. Do I have a closed circle anywhere at x equals 4? Not really, right? So guess what? F of 4 is undefined. We don't have a value at f of 4. So what I'm going to do is I'm going to go back to my Canvas and say that f of 4 does not exist or is undefined because we have an open circle. Okay, what's next one? Limit as x approaches 4. Now, we're talking, I love the order. Now, this one, though, is asking for something very different. They're not asking you for the function value. They're asking you where it is trying to go to. So remember in class I talked about something like this. If you have 0.9, 0.99, 0.999, 0.999, you got the idea, right? This number sequence is trying to approach what? If I continue to write it, it's going to get really close to 1, right? It's not going to get to 1 because 0.999999 repeating, it's not really 1, right? But it's approaching 1, isn't it? So it doesn't have to have a b at that exact value. So what I'm trying to say is, if I'm trying to approach 4 from the left, trying to approach 4 from the left of the graph, is trying to go to this open circle. And if I'm trying to approach 4 from the right side of the graph, is still approaching that same open circle, which is at 4, 2. So it's funny, the function is not defined at x equals 4, but the limit does exist. Okay? As x is approaching 4, this function is going to what? 2. It's not really going to, it's trying to go to 2. We have an open circle at 2. So the limit is actually 2. Oh, okay. So let me go and click on 2 for this problem. 2. Next. All right, what's next? the limit as x approaches -5. Let's see, -5 from which side? They didn't say it. So we need to make sure that the left-hand limit and the right-hand limit is the same. They're the same. So let's see. So -5 is right here, guys. Okay, -5 is right here. If I'm trying to approach that green line from the left, I'm going straight up. I'm going to positive infinity, right? But if I'm trying to approach that green line from the right, notice that I'm going down. I'm going to negative infinity. So guess what? Positive infinity does not equal negative infinity. And in this case, what should we say? We should say that the limit does not exist. Does not exist. Number 4, I have limit as x approaches -4. So -4 from which direction? They didn't say it. So I just want to make sure that the left-hand limit and the right-hand limit is matching. So let me see. If I'm approaching -4 from the left, I'm going to this value right here, that point right there. If I'm going to -4 from the right side of the graph, I gotta jump a little bit and jump a little bit, but I'm trying to go to this point right there. They're trying to go to the same point, right? What is the y value? What is the y value of that very point? The y value is 0. So we do have a function. I mean, I would love to talk about continuity. I want to talk about continuity next Monday. But this function is continuous at -4, 0, right? So the limit and the function value itself is equal. We should talk about that on Monday, really. I should save it. But for right now, limit is 0. Limit is 0 because we do have that matching left-hand limit and the right-hand limit. They're both going to the y value of 0. So I'm going to go ahead and say the limit is 0. Next, number 5. Okay, ooh, this one though, guys, this one is a one-sided limit. How do I know that? Because notice that symbol right here, approach -5 from the, I should write it, approach -5 from the right. From the right, okay? Because of the symbol, this plus sign right there. You're approaching -5 from the right. So what should we do? Start somewhere on the right side of the graph. Start somewhere on the right side of the graph of 5 and try to go to 5. I'm sorry, that is not 5. That is -5. So I gotta keep on going to the negative. I'm trying to go to -5. And, oh, I see where -5 is. -5 is where we have that vertical asymptote. And as I'm going to -5 from the right side, guess where I'm going? I'm going down to negative infinity. Do you see how the graph is going down as we are trying to reach -5 from the right side? So the answer is going to be -5. -5. Next. All right. How about, this one's a little different. X is approaching negative infinity. We talked about these today. What that means is, what does that mean? This means that X is going to a really, really, really small number, or I should just say, we're talking about because imagine the x-axis, guys, is this horizontal axis, right? This horizontal line. So if x is getting really, really, really small, notice we're going -1, -2, -3, -4, keep on going to like -1 million. We'll keep on going to which side? We're going to the left, right? So what they are asking is this, symbol, x is going to negative infinity. This is really talking about the left end behavior. And you learned about end behaviors in pre-calculus 161. So what we are finding is the left end behavior of this graph. So as you continue to go to the left side of this graph, what will happen? So I'm following the graph, but keep on going to the left. Can you see that there was an arrow right there? This graph is going to go up. It's going to go up to positive infinity. So the limit that they're asking for right here is going to be positive infinity because the left end of this graph is going up. Positive infinity because it's going up. All right, number 7. How about this? Limit at -2. Let's see. -2 is right here. You know, I just made a mistake, right? See, I told you, I be doing this really. That's not -2, that's +2, Sue. All right, so I better go ahead and highlight -2 really. This is -2 right here. So I need to make sure that the left-hand limit matches the right-hand limit. So what I'm approaching from the left, which is that open circle right there, and if I'm approaching that same point, I'm also still going to that same open circle. So I know, I agree, guys, we have an open circle here. So open circle means the function value is not defined at that very point, but limit can be an open circle, okay? They can both be trying to go to this point right here, this open circle. So I'll say that the limit is 2. They're both trying to go to this open circle from left and right. So limit is going to be 2. Limit is 2. But here's the thing, if they were asking for f of -2, I would have said does not exist because there is no open filled in circle here at x equals -2. I think we're almost done. Number 8, what about at x equals 1? X equals 1. Now, well guys, here's the thing. F of 1 is 3, I agree. Because there's a closed circle at 1, 3. But that's not what they're asking, right? They're asking, look at the graph and follow the graph from the left of 1 and from right of 1. Where is this graph approaching? Where is it trying to go to? From left and right. Because that point right there is just a sudden jump. Okay, that doesn't fit the rest of the graph. But, you know, if we continue to follow this graph, they will actually meet at that open circle, right? They will actually meet at that open circle. And that open circle has a y value of 1. So I will say that the limit is actually 1. Now notice the function value is not the same thing as the limit at that x value. Okay? And we'll talk about in order for a function to be continuous, limit and the function value must be the same when we talk about continuity on next Monday. But for right now, I'm happy because I found the limit. Limit is 1. I wonder if I can just delete it. Okay, limit is 1. I think this is a little too long, guys. Well, it's okay. I think I got 3 more. All right, next one. Approach -5 from the left. All right, let's try this one. I love writing on it because it helps me see. We're approaching -5 from the left. Approach -5 from the left. So somewhere that is smaller than -5, I'm going to try to go to -5. Now again, -5 is where we have that vertical asymptote. So if I'm trying to follow this graph and trying to go to -5, as you can see, the graph is going straight up. So the answer will be positive infinity. Okay. All right, what about this one? Approach -3 from the left. Okay, they're saying approach -3 from the left. -3 from the left. And guys, -3 is right here. -3 is right here. So from the left of this graph, I'm going to try to go to -3. And the right graph, the graph that is to the right of it, as we get closer and closer to -3, we're going to this very value of, what's that? X value, a y value of 2. We have a closed circle right there. So I will say the answer is 2 for this one. Okay? 2. Oh, I'm so glad I looked at it one more time. Because, guys, I just made a mistake, don't you think? I was doing the right-hand limit. I was doing the right-hand limit. Okay. I'm sorry, I even wrote down that I'm approaching -3 from the left, and I was following the graph from the right. That was my mistake. So go to -3 from the left. So I'm just kind of tracing the left. And here we go, here we go. If I start from somewhere left of the -3 and try to go to this -3, I end up at that open circle. And the open circle has a y value of 1. So the answer is going to be 1. Oh, I'm so glad I caught that mistake. 1. See, guys, if you do it so quickly, even though if you know what you are doing, you can make a silly mistake like that. All right, now this one, I think I just did it. Because by mistake, right? I'm approaching -3 from the right this time. I'm approaching -3 from the right this time. So if I follow it one more time, I am gonna go to that solid circle, okay, that filled in circle, which has a y value of 2. So the answer for this one is 2. Okay, answer for this one is 2. Now notice the left hand limit and the right hand limit does not match. They were different. So if they ask me the limit at x equals -3, I will say does not exist. Now what's the very last one? They want me to find f of 1. This is not a limit question. This is a evaluating function value. So I'm looking for a filled in circle. Okay, closed circle. At x equals 1, okay, we have a filled-in circle or a closed circle right here at 1, 3. So f of 1 is equal to 3, okay? Now remember, for the evaluating functions, go with the closed circle, okay? Limit can be an open circle, but function value must be a filled-in circle, okay? So the answer is 3 for the last one. Guys, I am about to submit this quiz. Hopefully I got 100 on it. Okay, upon submission, you will not be able to change your answers. Are you ready to submit? Yes. But listen, you guys can retake this over and over again, like I said, until you get 100%. But if you watched this and did it with me, you should be okay. You should probably get 100. What? Guys, it's saying that I missed the question. So let me go and find that one. Oh, what did I do? This one? Oh, I think I misclicked it. Oh, didn't we talk about how as it's approaching -5, it's actually going straight down, therefore -infinity. I don't know why I clicked -5. Well, that just means I have to take this all over again. But I don't think I'm going to take this all over again. You got the idea. I don't know what I did. Maybe I just misclicked it. So, that's it. I'm going to go ahead and exit the preview. Well, I am just going to stop at 92%, but you shouldn't. You should keep going until you get that 100%. But I am done with this quiz. Email me if you have any other questions. Reading limit in the graph can be kind of confusing because you have to follow the graph from the left and the right and everything. So I'll be happy to work with you during my office hour. But otherwise, continue to work on your homework 1.1 on My Math Lab, and I will see you next Monday. Everybody have a great